Hello, this is Professor Jim Caffey, and this is Chapter 6 on Astronomical Instruments. Chapter 6 on Astronomical Instruments here. First, we take a look at the Hubble Space Telescope. This has been in space since 1990, coming up on 30 years in space, and it will soon be replaced. Here is a region of space very common to amateur astronomers, the Orion Nebula and Orion's Belt. Here are the shoulders, feet of Orion here, and here is Orion's Belt. In the middle of the belt, come down from the middle star, and there is the Orion Nebula. So in different wavelengths, it looks different ways. Here are two pre-telescopic observatories. One is Machu Picchu in Peru. The other one is Stonehenge in England. The formation of an image by a simple lens has parallel light coming into the lens, being focused all into a focus point. And that is where you would view the image in focus. The difference between refracting telescopes and reflecting telescopes is that basically refracting telescopes bend light through a lens, a glass lens, whereas a reflecting telescope reflects light off of a mirror to another mirror that then goes to an eyepiece, which is a lens. You can have different areas of focus in a reflecting telescope. You can have it coming out the aperture, the eyepiece, or a focus within the mirror itself. Here is a very large telescope mirror. This is going to go on the European Southern Observatory's very large telescope. We like to name our instruments and telescopes interesting names. Here are some modern reflecting telescopes. The Palomar 5-meter reflector up here, left side, and the Gemini North 8-meter telescope over here to the right. Of course, we think that 36 eyes are better than one. In order to build a compact but very large telescope, we can use segmented mirrors. These segments here are all glued together to make one large mirror. And this is for the Keck telescope in Hawaii. But George Hale led to work of the construction of several major telescopes. The largest refractor bending telescope in the world is a 40-inch. This is in Chicago. Most observatories are put as far high up on a mountain as they can go. Here we have a high and dry site at Chile's Atacama Desert, part of the European Southern Observatory. Now we can put pistons on the back of these telescope mirrors, and these pistons can move the mirror ever so slightly to correct it for the atmosphere, and that's called adaptive or active optics. So here is a picture of Jupiter with those active optics working, and you get a great image. Well, the backbone of these cameras are the CCDs. They're called charge coupled devices. And it's basically a silicon wafer that is sensitive to light. In the infrared, we can see these hands in the bag very clearly in the infrared. Infrared gives off heat radiation. In a prism spectrometer, this is an instrument that will split up the light from white light into its colorful rainbow pattern. Here's the first radio telescope, very basic. This telescope was used by Jansky in his discovery of radio radiation from the Milky Way. And this is what a radio image looks like. There is a galaxy right here in the middle that doesn't give off very much radio information. But coming off two lobes far out into space, we see jets coming from this image. The Green Bank Telescope in West Virginia is pretty large, 100 meters across. The Large Millimeter Array in Chile, the Atacama Desert again, in northern Chile. Or you can put radio telescopes throughout the Earth and link them all together so that the Earth is acting like a radio dish, the entire Earth. The largest radio and radar dish in the world is the Arecibo Observatory down in Puerto Rico. We can put observatories into the upper atmosphere. SOFIA allows us to do that and get above most of the Earth's water vapor, which is blinding to infrared light. The Spitzer Space Telescope does infrared images like these. And then we have images like this. This is the Hubble Ultra Deep Field. And this is an area of space that we can go back into 13 billion years ago when it was formed, like looking back into time. The Chandra X-ray satellite does the same thing, but for X-rays. And then coming up in 2021 is the James Webb Space Telescope to be launched, and it's going through some very rigorous testing right now. And then the European Extremely Large Telescope will be almost 40 meters across, and this is currently under construction in Chile. We thank you for joining us for Chapter 6.